Okay, welcome back everybody. Hopefully you've all had a chance to get some food. And now we're just going to get started straight away into this afternoon's two sessions. And we're going to start with our developer APIs and SDKs. Specifically, the APIs and SDKs that we use to build custom-focused applications or to automate the experiences of ArcGIS through the Python API. So you can automate through Python. You can extend ArcGIS Pro to build a desktop application that has a more focused feel to it. Or you could use one of our Maps SDKs, one of the 8 Maps SDKs to build applications. Or you could use open source APIs if that's what you prefer to do. But all of these APIs sit on top of a set of location services that are provided by ArcGIS Enterprise, Location Platform, and ArcGIS Online. So today, when we're building our applications, we typically are application developers tapping into services. Now, if you're working with ArcGIS, that's location services. And we have a very robust set of these services, and we continue to enhance them with new capabilities as well as adding brand new services. So if we just take a look at some of the work that we've done over the last 12 months with geocoding, we added a brand new capability for batch geocoding. Now we've always had the ability to batch requests where we can generate results for maybe 100 addresses at a time, but this batch geocoding is all about geocoding millions of addresses in a very efficient way, where it's done in an asynchronous process, where you upload a file containing the addresses, and then once the process is finished, you download the results to your machine, and the file contains all the matched addresses, as well as any problem addresses that it's come across. There's also a facility that we refer to as drill down. That's where you can perhaps, you know the address of a tower block, but you don't know all the individual addresses within the tower block. Drill down allows you to, using that one address, drill down into all the addresses and retrieve these from the service. For routing, 2 new capabilities: last mile delivery. It's all about making that last mile delivery. Think of it like a parcel delivery service. Snap to roads is about data cleaning operations, where you might have a GPX track that you've been recording for a vehicle, but it's not quite on the road because of the vagaries of GPS, especially in a built-up environment. You can run that GPX track through our Snap to Roads service, and it snaps the points onto the road segments, but it also potentially adds extra information if you request it. Perhaps the speed limit, etc., gets added onto your features. And finally, the team's been really focusing on performance. And over the last 12 months, we've seen about a 40% gain in performance for our routing services. And that's the services that we host. It's also potentially the services that you host on your own street networks and powered by ArcGIS Enterprise. A brand new service for worldwide elevation, where you can give it an XY or a series of XY coordinates, and we will add the Z value for the elevation. And in the area of base maps, a number of new services and enhancements have been made. We've got a brand new static base map tile service. That's where we can convert vector tiles into image chips and deliver them to clients that don't perhaps understand the vector tile format. Open base maps has been enhanced with the Overture data sources, and we've moved away from Street Map as one of the sources for open content for our base maps. We've got a new session-based pricing model if you're using Location Platform. So Location Platform is all about transactions against the service, and you pay for what you use. And for base maps, it's traditionally been every tile I request from the base map, I'm going to pay for. With session-based pricing, you start a session, you pay for that session once, and you can retrieve as many tiles as you like. And it's always just that one simple charge. So for certain longer running use cases, that's a much more efficient way of working with the service. And that's unique to Location Platform as the product. And then most recently, we've released a new service called the Static Maps. The Static Map service is all about embeddable map images. It's really for when you don't want to load a full mapping library into the client that you're using to interact with the service. You want the service to render the map image on the back end for you to simply use it in your client application. So if that's a web page, it could be a very simple web page, no dynamic page loading, no JavaScript library required to display an image on an HTML page. But it could also be another application. Maybe it's an email process where you need to put an image into an email, maybe for receipt purposes, or maybe inside of a ride sharing application where you often get these little thumbnails that shows you the route that you've taken. So the Static Map service is perfect for that. And it generates a map using any of our base maps as a style, but you can arbitrarily put some graphics on there, points, lines, and polygons. And you can see there's a QR code there to the beta program. All you need to do is go to that website that's pointed to by the QR code, and you can sign up for the new Static Map service. This will be coming out in final availability round about just before our user conference, which is in July. We think it'll be the last week in June when this will be made available for general availability. Open source mapping libraries. In the past, we've been a little bit ambiguous about our support. Do we support open source? Do we not support it? We absolutely do support building applications using open source web mapping libraries, connecting to our services. In fact, over the last several years, we've enhanced a number of our services so they work better inside of open source mapping clients. Because as a developer, you have choices, and some developers just prefer to use open source technology. That's absolutely fine. And we encourage you to use your open source libraries connecting to services coming from ArcGIS. We support the four most popular ones for 2D mapping: Leaflet, OpenLayers, MapLibre. For 3D, Cesium, JS. All of these are supported against ArcGIS location services. And what we're seeing is a general trend that developers would, if available, they would prefer to use a plugin, an ArcGIS plugin for their open source library, a plugin that optimizes the use of ArcGIS, makes it easier, but also makes it more performant when you're working with open source mapping libraries. So to show us some of the new capabilities within the MapLibre open source mapping library, I'm going to pass it over to Piramu.
Thanks, Jon. As developers, most of us would love to build a lightweight, location-based applications. And open source mapping libraries really make that accessible. The app that I built is a good example of this. It uses MapLibre GLJS alongside ArcGIS location services to bring together the best of both the worlds. To simplify working with ArcGIS services, Esri has an open source library called ArcGIS REST.js. It is designed to work seamlessly with any client-side mapping libraries, including MapLibre, by providing wrapper classes that simplify integrating ArcGIS services into your application. Esri also has MapLibre ArcGIS plugin that handles base map styles, feature layers, and vector tile layers. In the application, I use the plugin to set the ArcGIS street base map and ArcGIS REST.js to find the hotels within the map extent and retrieve their information. So if we look at the code, I use the base map style class from the plugin to set the base map style and find places within extent and get place details operations from ArcGIS REST.js to find the places within the extent and return their attribute information, including street address. This is just one example how you can combine open source technologies with ArcGIS services. Now that we know most of you are building GIS applications that need to connect to users' authoritative content from a feature layer or a portal item content into your open source library. So let me show you what it typically looks like. In a standard map library setup, you would retrieve features from a feature layer as GeoJSON. And here is the app that exactly does this. It is trying to display features from a building footprints layer, but as you can see, due to the scalability of GeoJSON, the performance is low and there is a hard limit on how many features can be displayed. These constraints really hold back what you can do with your data. But that's where MapLibrary ArcGIS plugin comes in. Its feature layer class fundamentally changes how the features are retrieved and displayed. So if you look at the network tab, now the features are retrieved as PBF tiles. This means features are now loaded on demand dynamically as you zoom and pan, thus improving the overall performance and user experience. Now that all the features are loading efficiently, I can take advantage of MapLibre's powerful visualization capabilities. So here I am, extruding the buildings based on their height and further styling them based on their construction year. All just with a few lines of code. So I access the feature layer class from the plugin and set my portal item ID, and I can also define my queries if I have any, and finally add the feature source and layers to the map. That's it, simple and clean. So we are just getting started with this, and we are committed to enhance our existing capabilities and create new features of ArcGIS, REST.js, and the new MapLibrary ArcGIS plugin. And we'll continue to identify more opportunities to help developers leverage our ArcGIS services within their preferred open source libraries. Thank you. Back to you, Yuval.
Thank you, Premu. So two great examples there, very lightweight, focused application that used location services and an open source mapping library for a great user experience, but also a GIS application that was connecting to feature services, but doing it in a very efficient way where you weren't restricted with the typical built-in support for feature services that come with these mapping libraries using GeoJSON. This time it was using the tile-based queries, exactly the same technology that's available in all of the ArcGIS client libraries. So that brings me to the ArcGIS mapping libraries. While open source can be attractive to many developers, if you want to fully exploit all of the capabilities from ArcGIS, you really need to start to use one of our mapping libraries. And we have 8 of them. We have the JavaScript API for web development. We've got Swift, Kotlin, Flutter, Qt, and .NET for desktop, mobile, and embedded development. And we've got 2 game engine SDKs as well for Unity and Unreal Engine if you want to build immersive game engine applications. And all of these APIs, they're designed to be extremely performant. They maximize the work that the server does as well as the client, and it really leverages the environments that they're working in, whether it's the modern browsers or modern mobile devices. All of them have got client-side analysis built in to the SDKs. There's many support for the various different types of data sources, whether these data sources are coming over the wire from a service or whether they're stored locally on the device. The Maps SDKs allow you to work with them. And ideally, they're really built to support all of your workflows. Your workflows, whether they're running online, offline, indoors, outdoors, the workflows that you need can be supported by one of the mapping libraries, or perhaps more than one of the mapping libraries that you use in conjunction with each other as you build out your solutions. So let's start looking at these Maps SDKs, and we'll start with the game engines. We support the 2 leading commercial game engines available to you today, Unity and Unreal Engine, and we typically see game engines being used to build applications that support digital twins. One of the videos that was playing at the start of this morning was showing a a port operations center in Vietnam that was all built using the Game Engine SDKs. This was sitting on Unreal Engine. But they built it because they really wanted a very accurate digital twin experience for many different types of port operator. We see them being used in simulation, where you really want that realism brought in, and you might be doing it for training or mission planning purposes. And we see simulation applications being built for public safety and defense and intel situations. And we see them being used to work with extended reality, where you're either taking a fully virtual world and where you're really immersing yourself in the digital world, or you're maybe doing something where you're blending the two. You're blending the real world with the digital world in an augmented reality situation, and game engines are great for doing that. And game engines, one, they provide fantastic rendering, but actually, let's be honest, all of our GIS clients support great rendering capabilities these days, whether it's on the desktop with Pro, or in the web browser with the JavaScript SDK, or it's on mobile devices with our native SDKs. So game engines need to do more than just visualization to make them attractive. And they do that with all the other subsystems that they support. A physics subsystem, a particle system, which makes it much easier for you to model the real world in a digital context. And that's why we see developers being attracted by these platforms. So what I'd like to do now is to play a video from a colleague of mine back from Redlands in California, and he's going to take us on a tour of some of the latest advancements of the game engines over the last few months.
I've created an application using our Game Engines SDK that allows me to explore a virtual, unique museum. In the museum, each exhibit is made up of a virtual tabletop that highlights a specific feature from our SDK. I'm currently in the 2025 showcase room, where I'll be showing off some of the features we released last year. I've just showed off my custom avatar that looks like me, and I've set up third-person character controls to navigate through the scene. Heading over to the first exhibit, we'll be taking a look at custom materials and how they can be used to see what others can't. In game engines, just about everything uses a custom material or shader in order to give objects a unique look. Built directly into the plugin, you can replace the default material 3D layers in order to fully customize your scene. Here, I'm utilizing a depth texture in order to render what is and isn't in view from a specific point of view, and changing the color accordingly. I'm using green for what is in view and red for what's not. Heading to the next table, we'll be taking a look at 3D tiles. Bringing them into the game engines allows you to truly appreciate their realism, and man, do they look good from this first-person point of view. But I can gain perspective from another vantage point. I can teleport myself directly into the scene in order to see the city streets of Boston and what it would be like for me to walk around there. I can continue using my third-person character controller in order to walk around by using the mesh colliders generated by our plugin. It looks super cool from this perspective, but I think I'm ready to head back into the museum. There's one more stop in the 2025 showcase room before I can head into the 2026 showcase. This last table showcases elevation. Last year, we introduced support for vertical coordinate systems and how they can be used to bring together different data sets with various different elevation sources. Here, we're looking at the island of Tenerife within the Canary Islands. And if that's not dramatic enough for you, I can use some game engine code in order to animate the elevation exaggeration factor so we can almost feel what it would be like to climb the mountain. I'm now ready to head into the 2026 showcase room, where I'll be showing off some of the new and upcoming features in our SDK later this year. The first exhibit I'll be showing off is support for Identify, which we recently released in our most recent release. Identify allows us to pull the attributes associated with a 3D layer directly from the layer itself, and I can display them on this nice UI here. Additionally, I can cycle through different buildings in order to see what other attributes I can grab. Additionally, I'm combining this with the custom materials I showed off earlier in order to give the building a distinct glow, so I know immediately which building I selected. Moving forward, every time we add a new 3D layer into the game engines, it will support this identify feature, assuming it has attributes. The next exhibit shows off a new layer coming soon to the Game Engines SDK, that being point cloud layers. Man, does it look super good in this scene. Not only do we support displaying the data itself, but we also support changing different renderers within the game engines using the API. I can cycle through different renderers here in order to see what else we can see. There's a couple different ones here, and they all look just as good as the first one. The last stop on this tour is another new 3D layer coming to the Game Engines SDK, point scene layers. Here, I'm taking a look at the trees of the city of Redlands within Sylvan Park. This is one of my favorite parks in the city of Redlands. The model symbols come directly from the ArcGIS services, which means we can change them directly in the game engine, giving us full control. I can cycle through different models like I'm doing so here, where we can use the realistic looking trees, or we can even change to something more stylized like a cartoony tree, or pull something straight out of a video game like Minecraft. I'm now ready to head onto the balcony where we can wrap up this tour and see all of the features I showed off come together. On the balcony, you'll be able to see 3D tiles, elevation, custom materials, and everything else that I showcased today. We can watch the sun go down, and it just looks so good. The game engine really does render things in a different light, and it makes things look so good.
Okay, thank you very much, Mason. During the video that Mason recorded, when he recorded it, he was talking about the upcoming release. I'm happy to say that everything that he showed you has now been released. We released the latest version of our Game Engine SDKs just 2 weeks ago. So everything in the video is available in the SDKs that can be downloaded from the developer's website or the various stores for the Unity and Unreal Engine. Let's move on to the native SDKs. They're really about building high-performance mobile, desktop, and embedded apps. Now, our JavaScript API does work on mobile platforms, and it does a good job, but if you want the best performing application, then you need a native SDK. Now, when I say the best, that could be the best for your end user, but it could also be the best for you as a developer, because the best debugging experience when you're building mobile applications is to use a mobile SDK, where you get full access to the machine and the device and all the information that a debugger can provide you. So it really makes you productive as a developer working within these mobile platforms. Our SDKs are supporting a variety of workflows out there, whether it's working from the field or you're just even working in the office, but you just prefer to do your work on a mobile device or even on a desktop. The native SDKs are there to support you. We've got 5 SDKs, .NET, Flutter, Kotlin, Qt, and Swift. And so we support you as a developer working in the environment and the framework that you want to work with. If you want to use a cross-platform technology, .NET, Flutter, and Qt have that capability. If you want to use the specialized SDK most specific to a platform, you could use Kotlin or you could use Swift. The choice is yours. All of them have their pros and cons, and but the important thing to say here is we're really trying to meet you where you do your work and not forcing you into one specific framework that we support. Now, when it comes to working offline, it's not an accident that our native SDKs work offline. It's by design. We design support for offline capabilities from the get-go. Anytime a new piece of functionality is envisioned for our native SDKs, we always think about how is it going to work offline as well as online, because we want our native SDKs to offer offline support and not really be in a disadvantage if you're disconnected from the network. So there's lots of patterns that you can use when you're working offline. You could be fully offline where the data gets loaded onto your device. You could be fully online where you're just connecting to the services, or you could be somewhere in between. The native SDKs will support all these different flexible patterns. Lots of data types are supported, whether it's the layers coming from services or whether it's from files or databases stored on the devices themselves. We typically see offline being used in data collection workflows, where you might be completely disconnected from the network. You still want to capture your data, and when you get a network connection, you synchronize the changes that you've made on your mobile device back to the servers, whether it's in enterprise or online or location platform. The team really has been working on a lot of major enhancements to support these mobile workflows. So again, I'm going to play a video here from Lucas and Devesh as they show us some of the enhancements in the area of editing offline, as well as working with local content coming from your mobile device.
Collecting and editing data in the field is critical for many organizations' workflows, but building great user experiences on a touchscreen device can present some unique challenges. I'm going to highlight 3 enhancements we've made that'll help you make great editing applications for your mobile devices. First up, we have the Reticle tool. The Reticle is a geometry editing tool purpose-built for touchscreen devices. Its fixed location in the center of the screen allows you to easily see your edit along with any snapping feedback without your fingertip getting in the way. We heard feedback from you that you'd like more control over the behavior of the reticle, so we took that feedback and came up with the programmatic reticle. With the programmatic reticle, you can define your own experiences, like this one where we have an action button that changes depending on the hover state. Currently, you can see that the reticle is in insert mode. If I tap my button, a vertex is inserted. If I move the reticle back over an existing vertex, notice how the button changes. It's now in pickup mode. I can tap the button to pick it up, pan the map, and tap the button again to put it back down. Finally, with the programmatic reticle tool, you can override all the gesture behaviors, such as the tap event. In this app, I've wired it up so that if I tap on a vertex, I'll center my reticle directly on the vertex. This makes it really easy to traverse and edit my entire geometry. Using the hooks provided in the programmatic reticle tool, you can build great user editing applications for your mobile devices. Next, we have group and preset templates. Consider a utility worker tasked with adding gas service lines to houses in a new subdivision. Traditionally, for each new house, the worker would need to add a service line, a T connection, an excess flow valve, and a service meter. This is time intensive and it's error prone. With group and preset templates, we can simplify that to 2 taps on the map. Here I can see all of the templates defined in my map. I'll start by searching for my service pipe group template. The group template will contain all of the sub-feature templates, as well as a primary geometry and a sketching tool needed to create all my features. I'll select my template and a tool, and with the help of the reticle and snapping, I'll sketch a line. When I finish my edit, you can see that all 4 features are created. I have the service pipe, excess flow valve, meter, and T all created in the right locations relative to each other. They have the proper attributes and symbology, and if desired, I can open up the feature form for each individual feature to make further edits. As you can see, using group and preset templates can dramatically simplify data creation. Lastly, we have editing associations and feature forms. Feature forms are user-friendly interfaces for editing attributes and attachments in ArcGIS. Through the power of Arcade, you can set conditions that will hide and show fields and auto-populate values, streamlining data input. Feature forms also support advanced data models like the utility network. Here, I'm looking at a feature form for a streetlight in an electric data set. I can view and edit attributes, as well as associations and attachments. When I open my attachment, I notice that this streetlight is mounted onto a pole. Within the utility network, this is typically modeled as two separate features with a structural association between them. Back in my form, I can see my structure association, so I'll tap that, in this case, a structure junction to an electric low voltage pole. I can show my associated feature on the map and access its feature form to make an edit. If desired, I could add or remove associations to other features as well. Today, I've shown you 3 enhancements that will make it easier than ever to perform sophisticated editing workflows on a mobile device. Now I'm going to pass it back to Devesh to show us another demo. Devesh?
Thanks, Lucas. In our last release, we added support for geospatial PDFs, which is a common format used by many of your organizations. In US wildland fire operations, they're used to distribute incident action plan maps like the one we see here of Canyon Fire. The blue dot shows my location, and the incident map helps me to understand things like the extent of the fire perimeter, shown here in red, and the location of drop points for essential personnel and supplies, shown here by the blue squares. Because incident maps are distributed in a standard format, they can be used across a variety of applications and can easily be shared with teams and organizations to provide a critical operational context. There are many ways your apps can import PDF files. In this case, I've already downloaded the latest incident map from the FTP site and saved it on the device, so I can go ahead and import it into my application and add it to my map as a new layer. This incident map is from August 9th. By adjusting the layer transparency, we can see just how the situation has changed in one day. Let's take a closer look. We can see that between August 8th and 9th, drop point 6 has been added to the western edge of the fire perimeter. And just south of it, a portion of the fire perimeter shown in black has been contained with control lines. In situational awareness applications, it is vital to have the latest information so you can make timely and well-informed decisions. And geospatial PDFs give you another great option to put authoritative data into the hands of your users.
Okay, thank you, Devesh and Lucas. Moving on to visualize and analyze. So when it comes to visualize, we've got great 2D visualization capabilities in our native SDKs. We've got really good 3D visualization capabilities, and we've had 3D visualization capabilities for a while. What's new is a new local scene capability. A local scene is one where you can pick the coordinate system that you're going to use, and you see it in a sort of a local perspective, rather than the global scene, which uses one coordinate system, WGS84, up until now. So that's a brand new capability built on top of a brand new technology stack, which we'll be improving and continuing to build out. And eventually this new technology stack for doing our rendering will replace all of the rendering technology that we currently have inside of our native SDKs. It's really the future come to us today. With on-device analysis, we've supported utility network analysis by tracing, analysis on transportation networks with optimized routing and associated operations. We've got geofences, which is providing situational sort of alerts based on the location context of the device itself. And the teams just released last month a brand new analysis engine that we refer to as the high performance analysis engine, and that's going to allow you to do spatial analysis operations which traditionally had to be done on the server. You can now do them all on the device, whether it's your mobile phone, your tablet, or your desktop. So to show us both the new 3D local scene and the high performance analysis engine, I'm going to pass it over to Ralph and Thad in this video here.
The next release of the native SDKs, we will be adding a new view, the local scene view. This view will allow you to load web scenes authored in local mode, or you can create your own. Local scenes are specifically designed to work with local 3D data in the coordinate system of your choice. This is especially important for architecture, engineering, and construction workflows where teams need to visualize and inspect detailed building and infrastructure models in real-world scenarios. Here on my tablet, I've loaded a local scene and zoomed to Ouray, Colorado. I can clip my scene to focus my work area and provide better context for my app users. Let's go ahead and explore this scene. You immediately get a sense of realism. Terrain is depth. We've added full edge rendering support, which makes these reference buildings here really pop. We've also added support for multi-LED models. Models further from the camera will show at a lower fidelity, whereas models closer to the camera will show at a higher fidelity. And this threshold changes dynamically based on the density of my scene. If performance starts to suffer, we'll favor the coarser models. We've also added support for materials, making metallic surfaces like this car shine, whereas this picnic table over here has a rough, textured, matte sort of look to it. We've also added support for emissive properties. Let's see that in action. Here, my scene will transition from day to night. Shadows move as the sun crosses the sky reddens as the sun sets, and my city lights up as the scene gets dark. The local scene view supports building scene layers, and those are the detailed building models that I mentioned earlier. You can apply filters to these buildings and enhance these filters with different rendering modes, such as wireframe, so you could really explore the inside of your building, or X-ray to focus your view. You can identify, select, and explore your pop-ups with these buildings. This scene contains well over 20,000 features in it, which results in about 60 million rendering primitives. It's quite a bit, yet my interactions are still smooth and snappy. This is because the local scene view is powered by an entirely new rendering backend designed to leverage the power of modern desktop and mobile GPUs and rendering APIs. The design efficiently uses device resources, maximizing your battery life, all while preventing this device from getting super hot while I'm using it. Because these are things we have to think about when we're building apps for mobile devices. And with that, I'll pass it over to Thad, who will demonstrate some additional native SDK up-and-coming technology.
Thanks, Ralph. The new high-performance spatial analysis API for our native SDKs leverages the device GPU to perform incredibly fast and responsive analysis. It provides a framework that allows you to chain together tools and operations, combine analysis from several input data sets, and quickly produce a result. Let me show you an app I've put together that highlights some of these features. My app displays a map of Arran, an island in western Scotland. It uses a 10-meter resolution elevation data set to create a viewshed for a location tapped on the map. The viewshed is updated as I move my finger across the display. Now I can't quite count this fast, but I'm told it's about 15 milliseconds to create a new viewshed at each location. With using local data on the device makes it even more performant. And it also allows you to perform analysis when you're disconnected from the network. Resolution of your analysis results is at the full resolution of the data, not the display. That means your results are consistent and accurate. Since all of the spatial analysis operations are implemented as a compute shader, a program that runs directly on the device GPU, display performance is amazingly fast. Okay, so that looks pretty good with one viewshed getting created dynamically. What if we were to have several viewsheds being updated? Like, for example, tracking a fleet of drones and evaluating which areas of the terrain are visible. My app simulates the display of 14 drones moving across the island and creates a viewshed for each drone to show the visible areas. Each drone updates its viewshed 20 times a second, which means my app is creating 280 viewsheds every second. And yet, as you can see, performance is snappy. But I still need to show you one of the more powerful aspects of the API, which is the ability to chain together tools and operations to get a result. I'm going to define an expression here that will be evaluated using map algebra and then incorporated into my analysis. In this case, I'm going to indicate that areas classified as forested in a separate land cover data set from the Living Atlas should be showed as obstructed in our analysis. And when I apply that, you can now see I have a new category of visibility showing me areas of limited visibility here in pink. Process chain optimization in the API means that regardless of how many operations I chain together this way, the compute shader that runs them will be recompiled on the fly and executed once, so performance remains excellent. I've shown you how the new Spatial Analysis API provides a set of tools and map algebra operations that you can chain together with several input data sets to produce your result. This API allows you to build applications that haven't been possible before. The resolution of your analysis results is at the full resolution of the data. It can be displayed in 2D or 3D. In addition to displaying your results, you can export them to a file and persist them on the local device. To bring it all together, the API leverages the power of modern GPUs and display pipelines for lightning-fast performance.
Okay, thank you, Ralph. And Thad, two really exciting technologies there, and I'm particularly excited by this new high-performance analysis engine, and we're going to be adding more and more tools into that framework so we can get the performance benefits from this modern framework with all the flexibility that you would expect from a GIS analysis capability. So that wraps up the native Maps SDKs. We've got one other SDK to talk about, and that's the ArcGIS Maps SDK for JavaScript. This is what you use when you're building web applications. Like all the others, performance is at the heart of this SDK. The team really works very diligently to ensure that all the capabilities that they add maximize the performance while running inside of the web browser. They really leverage all the capabilities of modern browsers, whether it's the ability to run a WebAssembly, or whether it's the ability to run on the GPU inside of the browser, or whether it's the ability to use web components in a standard way as part of a browser. The team's constantly looking at this very fast-paced moving environment that is your modern browser and incorporating these capabilities directly into the SDK. It's got tremendous 3D capabilities, and we keep on adding to them. You'll see Gaussian splats, the most recent data type that's been added, and we'll get a demonstration of that in a few minutes. Lots of interactivity with analysis, because it's not about reaching always back into the server to do the analysis. There's quite a bit of analysis that you can do on the client side, so that even in the web browser, you can build very interactive user experiences for your users. Dynamic visualizations lie at the heart of a lot of WebGIS, and so the JavaScript SDK fully supports tremendous visualization capabilities. And most recently, the team's been working on rolling out a lot of capabilities wrapped up inside of web components, which makes it very easy for you as developers to get up and running. 3D on the web is not a futuristic thing, it's here today. We've seen a number of examples of fantastic experiences built on top of the JavaScript SDK, all inside of 3D, whether it's client-side analytics, whether it's visualization with a variety of layers type support and general capabilities, or whether it's just the data management connecting to all the different 3D data sources that are available nowadays. The JavaScript SDK is set up to support you as a developer to build web-based 3D experiences. What I'd like to do now is pass over to Madhubala, who's going to show us how you can build 3D applications with the JavaScript SDK, and specifically some of the new capabilities that the team's been working on.
Thank you, Yuan. Hello, everyone. In this 3D scene, in this 3D scene, you are looking at an integrated mesh focused on stockpiles. In this scenario, you could start with 2D site plan that allocates area for each different material, like these polygons. So before latest releases, I could already calculate the area, but what I really wanted to do is to calculate the volume. So let me show you. This is the area calculation. So since recently in JavaScript SDK, I can programmatically use these polygons as an input to calculate the volume of the stockpiles on top of the integrated mesh. The volumes are represented in green color in the scene, and the values are shown in the cut labels. I can also fine-tune the boundaries of the calculated volume analysis against the reality of the mesh, so that the calculated volume is precise as possible. And this is not just visual result, you can also extract the numerical values and show it in UI or feed it to a custom workflow. Alright, now let's switch from analysis to visualization and see how we can use some of the new capabilities to make things really stand out in a 3D context. While reviewing a proposed building, you need to consider the surrounding. But in a dense 3D scene, icons might end up behind the building. So first let me show you. Using the focus area, I can dim everything beyond 5-minute walk from the specific building and keep the focus on what really matters. And also, we have introduced new property for the icons and labels called occluded visibility. The new automatic mode is adaptive. It increases readability and reduces clutter by making the occluded icons transparent as we navigate through the scene. Or I can set it to hidden so that we can only see the non-occluded icons, or I can set it to visible and the POIs will be visible even if they are behind or within a 3D object like this emergency exits here. To really emphasize key elements, we now support emissive materials and glow. Let me explain what I mean. This building model already has elements that are meant to emit light, such as these LED strips are shining through window. So when the scene gets darker, by simply enabling glow on the scene component, those emitting objects get a soft halo around it, which creates a stunning effect and makes the building stand out clearly in the scene. And this is not just limited to models. You can also set an emissive property to a volumetric 3D symbology like 3D points, paths, or extruded polygons, and create glowing symbols like I did for this custom floor selector. Let's keep going and look at another way to visualize data in 3D. Magnitude and direction data like wind, ocean currents, or flood simulations have been visualized in 2D using the flow renderer for quite some time. Now we can also use flow renderer in 3D. While navigating the globe, you can really see how the flow behaves across different regions, continents, and countries. But this also enables new ways to vertically explore the data. For example, I can push in the flow at an absolute height to analyze it in isolation, or I can set the mode relative to ground and visualize the wind at its real sampling height following the terrain below. Let it load a bit. Yeah, so I can zoom in and analyze the pattern on this mountain. To conclude, I am excited to share that we now support Gaussian splat layer on the web, which is the right choice for you if you need an ultra-realistic 3D representation. The smallest details, like this insulator of the substation, can be inspected with incredible fidelity, capturing fine wires and structures that traditional layers usually struggle to represent. This 3D layer is now integrated into our ecosystem, so you can measure the wires and other structures to get the accurate picture of the site without having to be physically there. So we have seen how these new capabilities extend what you can build in 3D web application using our SDK. For example, how to programmatically use the analysis framework, or how to make key elements stand out in 3D, and finally how the new Gaussian splat layer can make your web scene feel more realistic and communicate a JS story to any audience. Back to you, Jan.
Thank you very much. So great enhancements there to 3D. Now, I mentioned that despite the fact that we're adding lots of capabilities into the SDK, we're also making it easier to consume these capabilities inside of modern browser frameworks and technologies. And we're doing that by building web components, and we're ultimately going to replace all of the widgets that we did have in the past in our JavaScript SDK. We're going to replace them with web components. And the nice thing about that is you're not having to learn a specific widget framework. You're a web developer who understands components, web components. Now you're going to understand the components that we ship as part of our SDK. They just plug in like any other component inside of your HTML. So to show us the latest with web components, I'm going to pass it straight back to Madhubala.
Thank you. Here we are in the map viewer, showing the helicopter activity and noise complaint web map that Ashita showed earlier. So here, there are a lot to see here. We have a really interactive pop-up and place of interest in bookmark and collection of charts like this calendar hit chart. So I'm going to use this web map to build an app to explore the relationship between the helicopter activity and the noise complaints. In ArcGIS Maps SDK for JavaScript, you have so many ways to get started building an app. Of course, we have the sample code and tutorials. One of the new ways to get started is ArcGIS Create CLI. So let me show that in my terminal. I will run the ArcGIS Create CLI command. It will take a few, So I'll give it a name first. And then I can select from some of the popular frameworks like React, Vite, Vue, Angular, and so on. Or else I can create a simple application using CDN. So I'm going to go with CDN. For now, it's downloading the project template from the GitHub. Once the template is downloaded, you can go and update it based on your requirement. The template uses Calcite, which is ESRI's design system for layout. Of course, we have the app shell and the navigation, which is the header, and you have the map component. For now, it's pointing to a default web map. You have a zoom, search, legend, and chart. So I have went ahead and updated the map component using the item ID of the New York noise complaint web map. And I have also added the bookmark and the chart component. So I find it amazing that earlier we had to write a lot of code just to set things up like the map and add the layers and manage everything manually. But now it's like I just add the map component and give the item ID and that's it. All the layers automatically come and display. So yeah, way less code and way less effort and everything just works. So let us go to the browser. Yeah, so this is my app. Here we have the web map, and when I click on the map we can see the pop-up, and I also have the legend, bookmark, and also the chart here. So I could call this done or continue building out an experience. So I want to build more tools. First, I will use Calcite to organize my experience into a panel. So when I click on a census tract, instead of showing the pop-up on the map, I have it embedded in my panel. Here you can see the pop-up and the details. And also I have embedded my chart into the panel too. Next, I want to explore the map from a statistical perspective. The good news is, in addition to the SDK modules, you also have full access to the underlying core JS library. So I was inspired by this sample, which creates a buffer around the cursor, and I can adjust the buffer length too, and as I move the cursor, it calculates the statistics on the fly. So I have created the same in my app. I have a 1 mile buffer around the cursor, so as I move it around, it calculates the population, per capita income, and noise complaints on the fly. So let me zoom to Central Park. Yeah, here you can see there are more than 7,000 noise complaints. Next, I want to explore the flights based on the day. So let me select a day. Since the chart and map are synced, when I select the day, the flight on that day are highlighted on the map. The highlights are useful for a lot of data sets, but in this case, the data is so dense with 7 lakh segments. Hence, highlights are really helpful. So instead of highlight, I am filtering the data based on day. So I'll select a day, and the flights view on that day are shown in the map, and the list of helicopter also shown here. So when I select a helicopter, the flight that particular helicopter took on that day is shown in the chart. And I'll select a flight. It's highlighted on the map. And I have also filtered the noise complaints which are within a half a mile buffer of that segment and that occurred on the same time window. So that we can conclude that this particular flight might have been contributing to some of these noise complaints. So I hope what you have taken from my demo is that you can be incredibly productive building apps with components in combination with your web map with very less code that gives you the opportunity to focus your effort on those custom workflows that are unique to your organization. Back to you, Yuan.
Thank you very much. So even though it's easy to get started with web components, if you need to go a little bit deeper in your application and get access to the full JavaScript API, that's available to you as well. Next up is web editing. Whether it's creating new features, working with tabular data, or whether you're really working with form-based editing to your features, the team's been working on a number of new capabilities to make these things easier. No more so than in True Curves. We're bringing True Curves across the ArcGIS system, and the JavaScript team has been working to make sure that in the web, True Curves are not left out. Whether these curves geometries are on graphics or on features, we've got full support for them. So what I'd like to do now is pass over to Piramu, and she's going to give us a demonstration of some of these new capabilities with web editing.
Thank you, Yuan. So we have some powerful enhancements in Drawing API to support true curves in 2D. This means drawing, editing, and snapping to true curves now built into the sketch and editor component. Let me walk you through the workflow that takes advantage of these true curve segment tools in Sketch. To show you that, I'm going to draw a cycling path along this park using some of the curve tools available. I'm going to use Sketch to draw a line with a custom line symbol that I've already set up. And you can notice how the toolbar updates to show the true curve segment tools. Let me start with some straight line segments. Then I switch to circular arc to create a curve around this area. Sketch now allows us to switch between different drawing tools while actively drawing a polyline and polygon geometries. And the supported curves we can create with this toolbar are circular and Bezier arcs. With Bezier arcs, you can use Bezier handles to modify the curve as you create the segment. And these handles are also available when you create and edit the geometries using Bezier arcs. This new segment-based drawing approach allows us to quickly switch between different drawing tools to create a smooth curve along this area. Now that I have drawn a path, I can use the print component to print this map, and I can further share it with others. TrueCurve support also extends in editing feature services natively through Editor component. Just like Sketch, Editor's drawing toolbar now includes TrueCurve segment tools. So here I have the building footprints mapping application centered on Sector 69 in Faridabad. I have drawn an area on map that was represented as a construction site. I have used circular arc to create this area to accurately match the natural boundary of the polygon. But I do notice that the border at the bottom right still looks straight. So I'm going to convert it to circular arc to better match the natural path. Now that I have updated the geometry, I can use the split tool to divide this area into two sections for different use cases. Thanks to split tool support for true curves, now I can split curved geometries. And splitting is made easier with snapping support for true curves, so I can snap this splitter line to the curved geometry and I can snap it back to the other end of the polygon to complete the cut. Now I can represent the first area as a residential site, and the second area would be represented as a commercial site. I do have an arcade expression running in the web map to calculate the area and converts the units to acres. Just like drawing and editing, arcade also supports TrueCurve. So now the polygon labels are updated to reflect the new units after I complete the edit. So we are done. So two-dimensional TrueCurve drawing and editing support in Sketch and Editor component really opens up the ability to perform more sophisticated editing on the web. Thank you. Back to you.
Thank you very much, Puramu. Next up is Parquet. It's a relatively new format. It's a very compact way of storing content. It's column sort of based, and it's really optimized for cloud storage situations, and it's fast becoming the most popular way for data scientists to work with large volumes of data. But it doesn't really have any spatial capabilities built into it. Now, there is a form called GeoParquet, which adds spatial columns or spatial capabilities into the Parquet format, but it doesn't have any spatial indexes. And we know how important spatial indexes are to us because the context spatially to the area that you're working within can really help optimize things. So what the team's been looking at is how developers are starting to use GeoParquet in building applications and looking at ways to optimize that for our users. Now, GeoParquet, as it stands, is good for small to medium-sized Parquet data files. But if you've got Parquet data files with millions or billions of records, it fast becomes unusable because you can't be expected to scan through the entire file to find the features that are relevant for the area of the map that you're working in. So what the team has done, it's worked on some new capabilities to actually add something. It's not a spatial index, but it can be conceptualized as something like a spatial index. And to show us this latest technology, I'd like to introduce Jitendra, and he's going to step us through the enhancements to GeoParquet to handle efficient handling of large Parquet spatially enabled data sets.
Thank you, Ivan. Imagine you are a data scientist working with millions or even billions of records in the cloud. Formats like Parquet make it easy to store and process that data at scale using tools like Spark and GeoAnalytics engine. But when it comes to visualizing that data on a map, things get complicated. You often need extra steps like building vector tiles and heavy post-processing just to make it usable. Today, we're changing that. Let's look at a new approach called spatially optimized Parquet. We start with something simple. A directory of Parquet files containing 11 million census blocks. With a single function with GeoDisplay, we optimize the data for visualization with an additional column. The output is still Parquet, but now it's smarter. It includes a spatial key, a sort order, and multi-scale geometries. What does this mean? It means the data is now ready not just for analysis, as I create charts and graphs, but also for direct mapping. Using the JavaScript Maps SDK, we create a Parquet layer and point straight to this file stored in the Azure bucket. As we pan and zoom, the app doesn't load everything. Instead, it streams only the data that's needed for the current view. Thanks to a Rust and WebAssembly-based engine. Zoom in, and you get higher resolution geometries. Zoom out, and it stays lightweight. At the core of this is a clever idea: space filling curves. They turn spatial data into a single dimension while preserving locality. Here, we take the extent of a feature and we convert that into a single integer key. By sorting on this key, we implicitly create a kind of multi-resolution grid that can be used to accelerate spatial operations. The best part of this approach is that it automatically leverages the page statistics that already exist in Parquet. And this isn't just theory. We can apply advanced visualizations like dot density renderer. Here, we draw one dot per 7 individuals. And I can also add effect to emphasize specific blocks. The Parquet layer from the JavaScript SDK uses the same rendering pipeline and client-side query capabilities as other map layers. Even more impressive, this scales too, to even larger data sets. Here, take the Overture global building footprint, for example. It has over 2.6 billion features spread across multiple Parquet files, each of size 25 GB. In this view of Delhi, there are about 1.4 million features. Because we dynamically stream in only the relevant parts of each file, we can instantly explore cities across the world, streaming only what is needed. This is just the beginning. We are rethinking how cloud native data moves from storage to insight to visualization seamlessly. And we are just getting started. Over to you, Ivan.
Okay, thank you very much, Tindra. Some really exciting new technology there. And you may be thinking, gosh, is this going to replace my feature layers? No, it's not going to replace your feature layers. It's designed to complement your feature layers. So some of the considerations when working with Parquet are, how big is the data set? How often does the data change in that data set? Parquet is great for large data sets that don't change very often. It does require you to manually manage and maintain these Parquet files, and there's overhead in doing that. Feature layers, on the other hand, they're built into and across the ArcGIS system. They're still the simplest and best case for many, many use cases that you currently are supporting with your solutions. Feature layers are editable, they're simple to manage, they're faster for small data sets to medium data sets, and they work across the entire ArcGIS ecosystem, no matter the client that you're working with. But Parquet could be an alternative for some very large data sets that don't change very often, where you want to deliver them as part of a web solution. So that wraps up our SDK for maps. But next, I'd like to talk about ArcGIS Pro. Now, one way to think about ArcGIS Pro is it's a very sophisticated and robust and complete professional desktop GIS. That's not the way that I think about it as a developer. I think about ArcGIS Pro as a very flexible framework that's going to allow me as a developer to build on top of it to deliver focused solutions that are powered by the sophisticated capabilities, but are presented in a much more streamlined user experience. Now, when it comes to Pro customizations, the easiest thing you can do is configure some of the tools on the ribbon, maybe on the quick access bar. You might author some tasks. You might put some Python scripts in the hands of your users. But to get full control over Pro, you're going to be wanting to use the .NET SDK. And for that, you have 4 options for customization. You can build add-ins, which allow you to start customizing tools and present them on the ribbon. You can build managed configurations where you take over the complete control of the application from the moment that it starts up in the splash screen that gets presented all the way through to the user experience presented to the user. You can have custom data sources supported with the plugin data source capability, and there's also a core host application, which is a separate headless application that runs the Pro framework for you to do data processing workflows. All of these can be used and utilized as Pro as a sort of a desktop development framework. All the time you're working with the Pro SDK, you've got the full capabilities of Pro available to you, from individual subsystems like catalogs and knowledge graphs and data to geoprocessing, where you can get access to that rich tool set available to the geoprocessing user. To show us ArcGIS Pro SDK in action, I'd like to pass it over to Nagalingam.
Thank you, Yuan. So I will demonstrate 2 configurations that show how ArcGIS Pro can be tailored to suit your organization's workflow. The first one is for the urban land records. Land records management is a critical job. It involves multiple roles, specialized roles such as cadastral technician, GIS map technician, and surveyors. Each role has its own responsibility and distinct workflow. So this makes us think of customizing Pro based on the role and workflow within an organization. My first demo touches upon this requirement. So here is a start page that has been customized to support various roles in this organization. I'm going to assume the role of cadastral technician who maintains the tax map and plots. Pro is initialized. Notice the ribbon. It is heavily customized. It only has the relevant tools for this workflow. All the other menus, toolbars, and tools have been removed. From the Active tab, I can switch between the different roles in this organization. From the available tools list, I can execute relevant tools such as merge parcels, split parcels, and import plots. So with configuration, you can achieve a deeper customization of Pro UI than you can do with an add-in. So here is a plot for new development. One of my key responsibilities is to place an easement for this plot. To place an easement, I'll use this tool. A new pop-up is displayed with two options. I can place easement for an underground power line or a water line. I'll select this option. A power line feature from the geodatabase is automatically buffered by 10 feet and added to the plot. For the next step, let me zoom in closer to check the easement. Yes, the easement has been successfully placed. So what you see is just an example of ArcGIS Pro running under configuration, customized to support the workflow of a cadastral technician in the Land Records Office. For the second demo, I'll show a configuration that leverages the powerful analytical and visualization capabilities of ArcGIS Pro. So this is my start page. My job is to perform the solar radiation analysis on the existing commercial and residential buildings to determine their suitability for solar panel installation. So I can choose my area of interest from here. Pro is initialized. Notice the streamlined UI. It only has the relevant tools for this analysis. Data is loading. Let's give some more time to load. There we go. On the right side is a doc pan created with Pro SDK. It shows the status of my workflow, which is almost completed. In the view, I have a 3D mesh data of my area of interest. With Pro SDK, you can integrate any geoprocessing tools into .NET workflow. So for this particular analysis, I'm using 4 geoprocessing tools. The parameter values in these UI components are being used by those tools. Let's begin my analysis. I have already captured the result of my solar radiation analysis into the building footprint layer. Now, I'm going to apply a standard symbology based on a template to categorize the solar suitability or solar potential into poor, good, and best. Now, I'll perform a visual analysis. The green buildings are having highest solar potential, but most of those buildings are having the solar panel installed. The yellow buildings are having less solar potential. I will ignore them. But these orange buildings are having good potential. Still, most of those buildings are having the solar panel installed. But this particular building doesn't have the solar panel. So this is going to be my candidate. So I'll do an identify to gather some information about this building. And I can share this information with my sales team. Yeah. This is a Pro notification with the status. So I can export this 3D data into GLTF format. GLTF is an open standard format for interactive 3D data, which can be shared across web and on the mobile device. The capability of exporting GLTF data with Pro SDK will be added in the next release. So with these 2 demonstrations, I hope I have given a fair idea of customizing ArcGIS Pro using a configuration pattern to suit your organization's workflow. Thank you. Back to you, Juan.
Thank you very much. I really like that second demonstration because it showed tapping into the power of geoprocessing, but still presenting it in a very easy-to-use, workflow-focused user experience. Last up is Python. And Python comes in 2 forms within ArcGIS, the Python API, which is really a Pythonic API onto the WebGIS architecture, and there's ArcPy, which is a Python API onto the tools and capabilities within ArcGIS Enterprise and ArcGIS Pro. And we can see Python being used throughout a variety of ArcGIS applications and experiences. It's even available in some of the Maps SDKs in the form of Qt and .NET. They have access to some commands and capabilities within Python. So what I'd like to do now is pass over to Benin, and he's going to show us enhancements both in ArcPy as well as the API for Python. Benin?
Yes, thank you, Yuval. All right. I'll quickly walk you through a curated preview of key productivity enhancements and on the horizon for ArcPy and Python API as well as Python for ArcGIS Pro. So in the ArcGIS Pro package manager, if you want to create a clone of the default package environment, it would do so by using the package cache that is present in the local app data folder. But if this is your first time cloning, then you will have to download the package cache. Now, in the latest version of ArcGIS Pro, we have now introduced the copy-based cloning. This is now the default method, but of course, we still have the previous method of cloning using the online. When I start a clone, if we check at the messages in the task, you can see the Conda Pro clone call. So this is the new offline cloning method to clone an environment. Disconnected machines will now be easily be available and you can easily create a custom Python environment. While my custom environment is, environment is still cloning, let's quickly take a look at the default Python environment. If you work with raster data, then you probably have worked with GDAL for analytics and processing. We now include the full distribution of GDAL right out of the box. So you can easily use those command lines tools such as GDAL translate with just the default Python environment, and if you're creating any clone using that environment. Many of you have also asked us for better pathlib support for string concatenation and all the other benefits that come with the object-oriented paths. So we have now integrated pathlib into ArcPy. What I mean by that is ArcPy functions and geoprocessing tools can now accept pathlib paths as input instead of strings. We have also added an environment variable that when we set it to true, it enables geoprocessing tools and ArcPy functions that returns a path to return it as a pathlib path instead of strings. Let's take ArcPy walk for example. Instead of using strings, we can now use pathlib paths for the input, output, and as you can see here, I have also taken advantage of the simple concatenation operator. You will also have the ease of cross-platform compatibility with your ArcPy scripts. So now let's take a quick look at the ArcGIS Pro debugger for Visual Studio Code, where we've made a few improvements. As part of the extension, we now have an ArcGIS Toolbox Explorer that opens in the side pane. If you have a project folder open, then this will list all the toolboxes within that project, what are the types of the tools, and the count on the number of tools within that folder. You can also expand the toolbox, see the tool as well as the script within it. Using this plus button, I can simply create a new tool just by mentioning a name. And here you go. We have also added ArcPy snippets in the ArcGIS Pro debugger extension. When you open the extension menu, we can see the insert ArcPy snippet. When I open that, you get a default list of snippets which you can use to create your script. But at the same time, if you have a block of code that you use often, you can save it as a custom snippet. Now, another highly asked for feature is the ability to create ArcGIS Pro projects using Python. This is now a possibility with Create ArcGIS Project. I'll just quickly run this. Yeah, so while that's running, Yeah. So this, all I need to do is just define the folder path and the project name. And it will take a couple of minutes, but it will definitely create a project file. Now, this is my folder where the project file should be created. So we'll just keep refreshing this, and the project file will definitely be created. Now, once the project file is created, you can access the APRX. Here we go, it is already created. So you can access this APRX, you can open it, you can create maps, you can add your layers from your database, and you can do a lot of things without even ever opening ArcGIS Pro. Okay, so now for some exciting new capabilities in ArcGIS API for Python. I'll show you how scripting with the ArcGIS API for Python enables developers to enhance and evolve applications and operational data. We'll go through two examples. The first is how to maintain consistent field app form configuration within multiple web apps. And second, how we can enhance operational data using the new AI utility services. We'll start with the mapping workflow, but the goal here isn't visualization, it's consistency. Let's say we're working with flood mitigation activity at a specific area. In our case, let's take Delhi. Okay, and we are performing the same activity in multiple states. So let's say that we have different operational web maps across all these states. Now, different crews, different locations, but the same data schema. Here I have a form which was created by the operational team, and it holds certain information that is required for the activity. But if you see for Kolkata, it is the same the different web map, but the form is not configured for this web map. Now, if I do this manually, there is a good possibility to induce inconsistencies, and it's going to take a lot of time. So I'm just going to automate it. Right. So I'll quickly run the cell, and we'll go line by line. Okay. So what I'll do is I will grab the web map that has the form configured within it. Okay? And then I will create a list of web maps where I want to apply this form to. Okay? And using the mapping classes of ArcGIS API for Python, I can apply the form configuration to all of the other web maps. And I can also update the expression if needed. Now, let's see if this run. Yes, this has run, and you can see that it has applied to 3 different web maps. I'll just quickly come here and we'll see if the changes is reflecting in this page. So, once this page has refreshed and loaded, we should see that the form that was created for Delhi should now be available for Kolkata as well. Here we go. So, what we did now, we defined one web map with one form, and we applied that to our other web maps. This transforms manual setup into repeatable governance. So now we are going to switch gears from configuration to operational data. Using the new ArcGIS AI utility services, it's still in beta, we can integrate text intelligence as well as image analysis directly into our GIS workflows. We're going to see an example of this using porthole data in Bengaluru. Okay, so this is the data that I have, and if I take a look at a feature, and if I look at the data over here, I can see a lot of data, what data was reported, what are the nodes that's been added, and I can also see an image that was submitted with the data. Now, so to make this more readable for us, or more on an informational basis, what I will do is first I will start with the image. I will define a prompt asking for image caption, tags, and severity, as well as the usability. And then for each image, I will pass its URL within the analyze image method. Next, for text analysis, I will again define a prompt asking for summary and priority. I will again pass each of the text to the analyze text method. And once this is done, I will update my feature at a go. Now let's just take a quick look at one feature so that we know that yes, new fields have been added and the new data has been updated as well. So let's take a look at this on the map. Here we see that the points that we had, the features that we had, are now segregated based on colors, based on its priority. So let's go for a high severe rate, and if we see, We now have an AI summary. We also have a severity assessment. And if we look at the image, yes, it does correspond with the AI analysis. And if we take out a low severity one, yes, it is a low severity one. So what I did here was, by integrating UI utility services directly into the GIS workflow, we were able to transform raw user data into informational GIS data, all within a single script. In conclusion, you saw how Python API gives control over the user experience and the data behind it in a way that is scalable as well as intelligent. Thank you.